This is lesson 64 in Saxon's Algebra 1, 3rd edition. And I've got a definition. This lesson is on domain and the additive property of inequality. So let's talk about domain for a minute. You talk about domain usually when you're talking about functions and you talk about domain and range and statistics and things. This website gives a slightly different definition for domain than your book does on page 261. And this website says domain of a function is the set of all possible input values. Your book says the set of permissible replacement values, often the x variable, but anyway, for the variables in a particular equation or inequality. And this domain, these input values, produce a valid output from a particular function. It is the set of all real numbers for which a function is mathematically defined. So most often a simple function's domain is all real numbers. And we're going to go on later and we're going to take this idea of domain and we're going to do a little bit more with it. For instance, the graph right here. This is a linear graph, but right now all you're going to be told to do is graph a specific set of numbers called the domain on a number line. So let's move on and get to that. So you can see it says graph x is greater than 2, but you have to now pay attention to your domain, which in this case is real numbers. So since it's greater than and not equal to, we put the open circle on the 2 and then the line and arrow going towards the right, getting larger because x is greater than 2. And real numbers includes everything in the middle of 2 and 3 and 3 and 4 and so on. Now this one you've got an extra step. It says x is not greater than or equal to 3. So let's find out what x is. Well, if it's not greater than or equal to, it has to be less than 3. Our domain for this is integers. And remember that integers are dots on the individual numbers. They include nothing in between, no fractional parts of the numbers. Now, if it is less than 3, we can't start at 3. We have to start at 2 and 1 and 0 and -1, -2, -3, -4, and so on. Alright, now this one says x is less than -1. So let's draw our number line. We'll put 0 right here. 1, 2, -1, -2, -3, -4. Now, we can only use positive integers. X is less than -1. So now this one's going to be a little different. Because we can only use positive integers, that would mean 1, 2, 3, and so forth. But x is less than -1, then we call this the empty set or the null set. There is no set of answers that will satisfy that equation given that domain. Okay, the next part of your lesson talks about the additive property of inequality. And it says that if A, B, and C are real numbers and A is greater than B, then we can say that if we added C to A and C to B, C being the same number, then A plus B is always going work that out? Well, you've got an inequality here. 2x plus 1 is less than or equal to 7. Well, the first thing we have to do is subtract 1 from each side, and we get 2x is less than or equal to 6. Then we divide by 2 on both sides, and we get x is less than or equal to 3. So you're going to have to take that process and then apply it to this graph that we've been doing. Alright, in this problem, A says x is not less than or equal to -2. So then we have to say that x is greater than, not less than or equal to, x is greater than -2. Now your domain is C, positive integers. So because we have to only use the positive integers, we're going to start at 1 and 2 and so forth. So the graph of our equation or inequality there is going to look like this. We start at positive 1 because we can only use positive integers. Okay, and B says x is not less than or equal to 4, so then we know that x must be greater than 4. My domain is reals, which includes everything on the number line, so I start at 4 and put an open circle, and then I'm going to put my line and my arrow going to the right, getting bigger and bigger because x is greater than 4. Alright, now here's one we're going to have to use that additive property of inequality. Let's turn it around first and say x minus 5 is greater than or equal to 0. Then we're going to add 5 to both sides, and we get x is greater than or equal to 5. But look at our domain. It is integers, so I have to start at 5 because it is equal to 5. A dot on 5, a dot on 6, a dot on 7, and so forth. Remember, integers are always going to be dots on the number line. Alright, and in this one we're also going to use that additive property. We're going to subtract 2 from both sides, and we get x is less than 3. Our domain, again, is integers, so we're going to have dots on the numbers, the integers that are less than 3. So that would be 2, 1, 0, -1, -2, -3, -4, and so on. Alright, so most of this is not new to you. This additive property of inequality is just like the additive property of equality. So you've been doing that, you know how to do it. The graphing is the only thing new. Graphing within a domain, a certain domain. So make sure you pay attention to what the domain says before you graph, and you'll be good. I'll see you next time for lesson 65.